Okay, so now we're going to start with module 4 of COA. The first topic is input output devices. Under input output devices, we need to know external devices, IO modules, programmed IO, interrupt driven IO, and direct memory access. Okay, so what are external devices? External devices are those devices that provides a means of exchanging data between external environment and the computer. That means through the external devices we can exchange our data between our external environment and with the computer. So external devices would be like external devices, like they are everything that sits outside the core CPU memory system. We know what are external devices. You can see, you know what are the external devices. We know keyboard is an external device, speaker is an external device. So this help us to connect with our external environment to the computer. Connecting external environment with the computer is what external devices do. Okay, exchanging data between, that is, if I'm speaking here and the speaking is an external environment and I wanted to the data that I'm speaking, I have to give it to the computer. How I'm giving it to the computer? Through the mic, which is an external device, right? So external device is nothing but it's a means of exchanging this data between the external environment and the computer. Now external devices is everything that is going to be sitting outside the core CPU memory system, but needs to communicate with it. Okay, but needs what? But we need to communicate with it through keyboards, monitors, and hard drives, network cards, sensors, printers, etc. So these are the computer connections to the real world. So these are the, so external devices would be outside our main CPU memory system part, right? These are all inside things, right? Outside we have this external devices. So these external devices help us to communicate with it through the CPU memory device. They provide a connection with the real world. They're creating a connection with the real world. Example is given as keyboard, monitors, printers, speakers, network cards, sensors, hard drives. These are the examples. Okay, now input output module means what? Input output module means it is the this is IO module, means input output module, which contains external devices as well as input devices. All these things are there in this. External devices mainly are there in this input output module. Now through this input output module we can connect, through the input output module, the connection between the external devices and the CPU and memory is basically happening. So an external device attached to the computer by a, so how the external devices are attached to a computer? Through a, right? So it is basically connected with a with the help of this input output module. So with the help of this input output module, basically we can connect this external devices with our CPU or memory. Fine. So the link is used to exchange. How this link basically do? They can exchange control status data between the IO module and external devices. Okay. Now we have to understand what are the three types of signals which is traveling across this link, across this IO module and external device. There is a link between them. That's through that we can connect this external devices with CPU. We need an input output module. Now there are three signals which can actually travel across this link. We have control signal, we have status signal, we have data signal. Control signal, what are they doing is that in controls, basically it is telling instructions, which is telling the device what to do, telling device what to do. It's like controlling the device, telling it, okay, what you have to do. Status is a device which is reporting its current state. To know the current state of whether it be the CPU or whether it be the external device's current state, what is the current state of it, that can be understood by the status. So control is telling the device what to do. To understand the current state, how it is in the reporting the current state is status. Data is the actual information that has to be exchanged between the CPU, memory and external devices. Understood? So here external devices don't connect directly to the CPU. It's not like the external devices are connected directly to the CPU. No, it's like they are basically connected through this input output module. Okay, this input output module is a dedicated hardware interface that manages the communication between the device and the rest of the computer system. So input output module is what? It's a hardware that basically actually it's an interface, hardware interface, which actually helps in managing this communication between our computer system. Computer system means it includes CPU, memory, and all of these things with the external devices. Now through this link, the three important signals which is going through this link is the control signal, status signal, and data signal. Control signal tells the device what to do. Status would report its current state. Data is the actual data, informations which is basically getting exchanged between them. The term peripheral device is commonly used to describe any external device which is connected with I/O module. Now, most of the time we will be, instead of external device, we will hear peripheral device. So peripheral device is nothing but to describe the external device which is connected to I/O module, we will use another term which is known as peripheral device. Okay, now let's see, there are three categories of external devices. We have, like you can see here, you have three categories for external device. The first is human readable device, the second is machine readable device, and the third is communication device. What are the three categories of external device? We have human readable device, we have machine readable device, we have communication device. Human readable device, which is suitable for communicating with a computer user. Like we humans can communicate with the humans communication, I would say. That is, these device interface directly with humans. For example, if you see keyboard, we are directly using this keyboard by typing whatever we want, and the output you can see through the monitor, right, or printer, whatever it be. So the examples are, if you see video display terminal, monitor, the keyboard, mic, we humans directly speak to the mic. Printers, whatever we want, we will say to the computer what things you want to print. Right, touch screen, we are touching our screen, and that how the screen is touched. In that way, the screen basically works fine. So human readable device are suitable for communicating with the computer users. So through these devices like the keyboard, the mic, the printers, the touch screen, we can communicate. That it helps the system to communicate with us, to the computer users. Such devices are called as human readable devices. So in short, those devices which helps the computer system to communicate with the computer's users directly. These devices interface directly with humans. These devices have interface directly with humans. These kind of devices are called as human readable devices. Their examples are given here. Now, machine readable devices is suitable for communicating with the equipment. That means these devices exchange data with other machines or system, not with humans. The data format is optimized for machine processing, not human readability. That means magnetic disk drives, tape system, sensors, and all these. Here you can see one example here. Input, sensor reading the computer. Output is what? Through the computer's motor or actuator, you can see. That means machine readable is like communication happening with the equipment itself. That is, these devices which is exchanging data with other machines or system, not with human directly. So it is suitable for communicating with what? So human readable was suitable for communicating with the computer user, but machine readable devices are suitable for communicating it with the equipments. So these these devices which we are talking, that is machine readable devices, can exchange data with other machines. Exchanging data with other machines. Example is the tape system, magnetic disk drives, and all are the examples. Now just understand that much. The communication device means it allows a computer to exchange data with a remote device, which may be a human readable device or a machine readable device or even other computer. So communication is like allowing a computer to exchange data with other devices. Other devices, you are like, For example, other computer, that is like Wi-Fi, network interface cards, modems, Bluetooth and all. Through Bluetooth, what we do, we are communicating, we are taking the data from the other device, right? So that which allows to allows the computer to exchange the data with other device. That can be human, which that device can be human readable device, machine readable device, or even other computers it can be. So such thing, that is, if you are taking the remote end, can be anything. That is, these devices connect the computer to a remote system over a network or communication link. So connecting the devices, that is communication devices, would be connected to a remote system, connected this computer to a remote system through this network or communication link. So the remote end, that is the remote system, can be other computer, it can be a printer in an office, or a server and all it can be. Example is the Wi-Fi, network interface cards, Bluetooth, etc. Okay, Wi-Fi's adapters, modems, Bluetooth modules, etc. are the different examples. So you have to understand that in communication devices, it allows a computer to exchange the data with other devices, other remote devices. The remote devices can be other computer, it can be other device which is connected, they are connected through a network or a communication link. Okay, so these devices allow the computer to connect to a remote system. So this remote system can be other computer or other printer in other office and all. So they are connected through a network or a communication link. These devices are basically connected. So the examples are network interface card, modem, Wi-Fi adapters, Bluetooth modules. Okay, so let's see here. So here, this much you have understood. There are three categories for external devices. We have human readable, which allow these devices allow the computer system to computer system with communicating with the computer user. Machine readable is like they are basically helps for communicating with the equipment, with other equipment. So these devices can basically communicate or exchange data with other machines or system. That is, example was the magnetic disk, tape system and all. Now communication devices, what does they do? They basically allows to exchange this data with other remote system, like other devices, other remote devices. That can be that devices can be human readable, machine readable, or even other computers, right? It can connect exchange data with other computers also through a network or a communication link. Such devices are called as the communication devices. The example was a network interface cards, modems, Wi-Fi adapters, Bluetooth modules. Okay, now let's see the nature of the external device. We have told that there are three signals. Control signals are there, then told you data signals, status signals. There are different signals which is going between them. So the interface to the I/O module can be in the form of control data and status signals. So let's see control signals. Control signals determine the function that the device will perform, what the device actually performs, such as send data to the I/O module, or is accepting data from the I/O module, or perform some control function particular to the device. Example, like we have studied in our hard disk, and or we have studied there is a head. So to control the position of that head, such things. So control signals are commands which is sent from the I/O module to the device, telling it what action to take, telling it what action. So control signals are like commands which is sent from the I/O modules to the device, telling it what it has to do, what the device has to do. So control signals is sent from whom? From the I/O module to the device. These control signals are sent, and it will tell the device what to do, whether it has to read or write. That is, whether it has to send some data, that is input, right? Send data from the device, or it has to accept the data, that is output, right option, or it has to perform some other device specific function if it has to do a particular function, like moving our disk head to the correct position, or if I want to move the disk head to track file. Doing such device orientated function, device specific function. So that will be managed by whom? The control signals. So control signals are nothing but the commands which is given to I/O module to tell I/O module what to do, whether it has to send some input, or whether it has to take some input, accept some data from the I/O module, or whether it has to perform some device specific function. What it has to do is decided. What the I/O module has to do is decided by the control signals. So they are just like some commands which are given from the I/O module to this external devices. Now data signals are what? Data are in the form of set of bits which has to be sent to, or it can be received from the IO module. So these carry the actual, these are the set of bits. Data are the set of bits. Data will be in the form what? Set of bits. These are the actual content, that is the real information which is flowing in either direction between the device and the module, in like between the device and IO module, and between the IO module and device, the two direction it can basically go. For a keyboard, this is a key code. For a disk, it's the bytes reading, bytes which is basically being read or written. For a keyboard, this is what? A key code. Okay, so data signals are nothing but data signals are in the form of set of bits which can be sent or received from the IO module. So this data is something which is basically containing the actual content. So the real information is the real information flowing in either direction, that is, it can go between the devices and IO module, and from the IO module in two direction this data can go. For a keyboard, if you consider, this is a key code. For the disk, it's the bytes being read, or key have different code. For keyboard, we have different keys in our keyboard. Each of these keys has some key code. So in keyboard's perspective, the data is key code. If you consider for disk, it's the bytes which is being read or written. For this case, it is bytes which is read or written. So data's different form we are talking. So data is basically in the form of set of bits, which is the actual content that is being exchanged between the device and the IO module. So if you consider for keyboard, the data would be like the key code. Whatever we have key we have pressed, that each key has a code. And for disk, it will be what? The bytes which is actually being read or written. Right. So status signal is what? Status signal is indicating the state of the device, in which state it is, whether it is in a ready state or not ready, to just show whether the device is ready for. So sometimes the device would be busy with some other thing. So for doing that particular task, that device would be not ready. So this status signal would say whether the state of the device is saying what is the current state of the device, whether it is ready or not ready. So what kind of signals it will send? Ready, not ready, or that is device is available but it is prepared. If it is ready, then the device is available and it is prepared for transfer. If it is not ready, the device is busy and it is warming up, or it is unavailable, it is what it means. Now if it's error, means something is went wrong, and if it is done, means the operation has been completed. If the operation, whatever operation is that is completed, is done. Error means what? Something has went wrong here. So these are the different status signals. We have ready, not ready, error and done. These are the different status signals. Fine. So this much we have understood what are the different signals. Control signals are there, data signal is there, status signal is there. Now let's understand what is happening inside the device. Inside the device, that is inside every external device, there are three internal components: the control logic, the transducer and the buffer. You can see inside, this is a block diagram for an external device, and always there is a control logic, there is a buffer and transducer. These are the transducer. These are the three important components which is there inside the external device. So that you have to understand the three important basically three important components which is present inside the device is this control logic, buffer and transducer. So if you see, control logic is associated with the device, controls the device operation, response to direction from the IO. Control logic is nothing but the brain of our external device. So it is a small circuit that interprets the control signal, which is, so IO module, I have told you the IO module will set control signals to this external device. So to interpret, to understand, this control logic is present inside our external device, which would interpret this control signals which is arriving from our IO module and drives the device's mechanical or electronic operations accordingly, and then it will make the device to do whether it be a mechanical work or whether it be an electronic operation, whatever it is, according to this control signals, it has to do one operation that is basically interpreted and made it happen through this control logic. For a disk drive, if you have understood, it moves the read or write head. For a printer, it controls the printer mechanism. So For disk drive, we have to move the read or write head. For printer, we have to do the printer mechanism. All these are controlled by whom? This control logic itself. So control logic is like the brain of our external device, which actually interprets this control signals that is coming from our IO module, and basically do the necessary mechanical as well as electronical operations that is required. Okay, so IO module would send control signals to whom? The control logic, and the control logic will make this device to drive the physical device operation, to do whatever operation. So through this control logic, the operations are basically done. Okay, now what do we mean by transducer? So if you see through this diagram, control signals are coming from the IO module to this control logic, and status signals will be given to the IO module. That means through the control logic, we will be understanding whether we have performed that, whether the system is ready, whether the status signals would be given out from the control logic itself, whether this whether the device is ready, whether the device has done that work, right? The status would be the later, after doing the particular operation, what we have to give to the IO module? The status, whether it has finished, then done. If it error occurred, then error. Whether the device is ready, then that status has to be given to the IO module according to the signals from the IO module itself. That is done by our control logic itself. Okay, now if you see transducer is converting the data from the electrical to other forms of energy during output. That is, transducer is a component that crosses the boundary between the electrical world of computing and the physical world. That means if I have input is a physical energy, okay, and I have to convert into electrical signal, and if my output is electrical, I have to convert into physical. These things are the conversion of this electrical forms, that is conversion of this data from electrical to other forms of energy. During the output, we have to convert this electrical to other form, that is right. And also from other forms, the input means what? Input, we are I am saying speaking something, so I have to convert that speaking to electrical form, right? That is done by this transducer in the devices. In its external device has this transducer, which would convert my physical energy, like my speaking energy, to the electronic energy, to this. So these conversion, and also my final output would come from the electronic energy, the output would be. So if there is a speaker, I have to get its physical form, right? So what it will be do, that conversion of this electrical to the physical is also done by transducer. So transducer is mainly used for what? Conversion of energy. If you consider disk drive, what kind of energy conversion is happening? Magnetic field energy to electrical signal to magnetic field, like that. And speaker, I told you, we have sound waves in the speaker. So the electrical signal that is coming, that is which is there in our computer, and we have to hear. How we can hear? Through sound waves. So that conversion of these electrical signal to sound waves, and through microphones, what happen? We are speaking in sound waves, that has to be converted to electrical signals. That conversion, printer is what is happening. Electrical signals has to be converted into that ink in the paper, right? So that is what printer is doing. So that conversion of this energy, temperature sensor, what it do? It will sense the heat. So heat signals has to be converted. Signal has to be converted to electrical voltage. Then only the temperature sensor can understand, okay, according to this heat, what is the electrical value, that is what would be its correct value. So these things, this conversion of the energy is basically happening with the help of this transducer, which is basically present here. So transducer can give data in and data out. That is, two things can happen. Data to and from the environment is happen this transducer, because from the transducer, the final output in which form you require is coming out. So data to and from the environment is happening through which this transducer itself. Fine. Now we have this buffer. Buffer is typically a buffer is associated with this transducer itself. You can see it's associated with the transducer itself, the buffer. So if you see, what does this buffer do? Buffer is a small temporary storage area that sits between this transducer and IO logic, between this IO module, okay, between the transducer and the IO module. It exists between the device and the IO module, may operate at different speed. The transducer may produce or consume data at a different rate than the IO module can handle. It smooths out timing mismatches. The buffer absorbs short bursts. So here buffer, what it do is temporary holding of data is happening through this buffer. A buffer can be up to 8 to 16 bits. That is, temporarily it can hold 8 to 16 bits, just enough to hold 1 unit of data, 1 unit of the data. So what happens is that sometimes what happens, if there will be speed batches, IO module may operate in different speed, device may operate in different speed. So we have to store this data somewhere before it is given to IO module, because of the speed differences, which we will discuss more detail when we are discussing other topics. So here we have to understand that this device and IO module have different speed. So the data may be there in our IO module, we have to store it somewhere. That temporary holding of data is basically buffer. It is like present in the transducer. It's like associated with the transducer itself, and it is like sitting between our transducer and the IO module itself. So the transducer may produce or consume data at different rate than that of the IO module can handle. It smooths out timing mismatches. The buffer absorbs short burst. So it smooths out the timing mismatch. That is what it doing. It is doing what? There are timing mismatch happening between this IO module and the device. To smooth out that timing mismatch, this buffer helps. So this transducer would produce or consume some data at different rate, and the IO module can handle. That means IO module timing and the transducer timing would be different. So there is a timing mismatch. So when this timing mismatch is happening, what happened is that to smooth out this timing mismatch, we have to store this data somewhere. That is why we have this buffer. Okay. So that is why there is buffer. Transducer may very fastly produce the data, and but IO module may not be ready to handle that data right now. So what happened? We will store it in the buffer, and whenever the IO module needs it, it can take from this temporary holding of the buffer. 8 to 16 bits of bits can be stored in the buffer. Like approximately 1 unit of data can only be held here in this buffer. Okay. So this is what buffer do. Fine. So this is about this diagram. Data bits to and from the IO module. This is the original data to and from the environment. This buffer is between the IO module and the transducer. Transducer is with the environment itself, connected with the environment itself. Then we have the control logic. This is a block diagram of our external device. Then IO module, if you consider, this is my IO module. Now this IO module, we told it can link to different peripheral devices. Now there are different system buses, that is address lines, data lines, control lines, which is from our system bus means what? CPU, different computer system connected buses, these different buses. So these different buses has to be connected to this IO module. Then only whatever the data, or if it's address or control and all is coming from the peripheral devices, it has to go to the computer system. So to the computer system, it can go through these buses. System bus, we have address line, data lines, and control lines. Through these buses, system buses, only this whatever be the data, the address or the control which is coming from this peripheral devices can go to the computer system. So this is how the model of IO is there, which is connected to a lot of peripheral devices. Then through the system bus, it can connect to what? Our computer system. So there is a system bus which includes the address line, data lines, and control line to connect it with the computer system. Understood? So this is how the basic generic model of IO works. Then we told about this block diagram of external device. In the block diagram of external device, there are three main internal components: control logic, buffer, and transducer. Control logic is basically the control signals from the IO module is going to this control signals. This control logic. The control logic is like a brain to our external device, right? It can basically do the necessary electronic or mechanical work, operation, whatever it has to do. It is done by this control logic, and the status signals is given to the IO module. Then we have the transducer, which can convert to whichever form, energy form. energy forms which is required. So it is connected directly to our environment itself. Then we have a buffer. Speed mismatching is to smooth out this speed mismatching between the transducer and the IO module. We have this buffer which stores temporarily, it stores some data bits, some bits of data, right? So this is what is happening from the control logic. The buffer and transducer would do the work. Fine. So to and from, that is why there are two arrows here. Understood? So these were our topics for this video. So we have understood these part. Then we told you there are I told you there are three signals. That is, we have control signals. Control signals would tell, it's a command which is coming from the IO module which tell the device what it has to do, whether it has to send the input, whether it has to take the input, whether it has to accept the input, right? Whether it has to do some device specific functions and all. Data signals is the actual data. If it is keyboard, then key code would be there, the actual content which has to be transferred between them. Now if it is disk and all, there are bytes for reading and writing. Status signals will tell us the current status, in which state this currently our device is there. Our device current state is given by the status signals. It can be ready, not ready, done, error. Okay. Then we talk about the different categories of external device. We have human readable, that is human readable device are these devices which helps to communicate with the computers users. Machine readable devices are helps to these devices would help to communicate with the equipment, right, suitable for communicating with other machines or system like magnetic disk drives, tape systems and all. Now communication devices are those which allows the communication with the remote devices. That can be external human readable devices, machine readable devices and all, right, or other devices, other computers, right, the Wi-Fi adapters, network interface cards, modems, Bluetooth and all. Now we talk about how the external devices are connected with our CPU or the computer system through this IO module. That's what we have said. And there is a hardware interface, hardware interface that is there, that actually manages this communication between the external devices and the computer system. Then we talk about what is external devices. External devices, those which helps to communicate, those devices which helps the computer system to communicate with the external environment, to exchange the data between the external environment. That's what external devices are. So this is the part 1. Thank you.